Hello everyone, welcome to our channel Higher Mathematics. In this video lecture, I am going to discuss next PYQ of Linear Algebra asked in csirnet 2019. So our question is, let A is equals to 2, 0, 5, 1, 2, 3, minus 1, 5, 1 matrix. The system of linear equation Ax is equals to y has solution for which value of y. So here, this is what? This is a non-homogeneous system of linear equation. So and matrix A is given. So the question is asked for what value of y the solution should be exist. So first we have to see if the determinant of the matrix is 0 or not. If the determinant is matrix is 0, then we have to further check for what value of y in the option there is a solution that is unique or infinite. But if the determinant is not equals to 0, then A inverse exists, and for each value of y there is a solution. So first we have to check the determinant of this matrix A. Determinant of this A is equals to determinant of 2, 0, 5, 1, 2, 3, minus 1, 5, 1. So first we have to find this determinant. 2 minus 15 plus, so here 0, so 0 into 1 plus 3 plus this 5 is equals to 5 plus 2. So what the determinant is, which is equals to 9. So we see the determinant of this matrix A is equals to 9, which is not equals to 0, which implies what? Which implies A inverse exists, right? A inverse exists, which implies what? Ax is equals to y is equals x is equals to A inverse of y for all y belongs to R3. So here for all y belongs to R3, x exists, that is solution exists. So here the option is set only for y is equals to 0, 0, 0, or y is equals to 0, y, 0, or only for y, 0, y is equals to 0, y, z. Here we see for every y belongs to this, the solution exists. So option D is correct, because the determinant is not equals to 0. So here we have only unique solution, whatever y is it. So our option D is correct. So this is a solution based on the system of linear equation. If you like this video, hit the like button, and for more such videos, subscribe my channel. Thank you for watching.